We learnt matrix addition and matrix multiplication in our previous videos. Now we move ahead to a very interesting topic, which is transpose of a matrix. Now transpose of a matrix is something very easy and very interesting. For example, if I have a matrix A given to me as A, B, C, D, E and F. So what is the order of this particular matrix? The order of this particular matrix is 2 into 3. Now transpose means I interchange the rows and the columns. That means the first row would become what? My first column. So what would happen? This would become A, B and C. And the second row would become what? My second column. So this would become D, E and F. So the resulting matrix that I'm getting is a 3 into 2 matrix. It is also denoted by the symbol AT. So please see in the notation form, if I have a matrix A as Aij M cross N, then the matrix obtained by interchanging the rows and columns is called the transpose of A. It is denoted by the symbol AT or A dash, and it gives me Aj N cross M. So you can make a note of this particular definition. That's the transpose of a matrix. So if I had a 2 into 3 matrix, I got a 3 into 2 matrix. If I have a 2 into 1 matrix, I would get a 1 into 2 matrix. If I have a 3 into 4 matrix, and if I transpose it, I would get a 4 into 3 matrix. So please do make a note of this. Now we have the properties of transpose. Properties of transpose. Now this is something very easy. That is A plus B whole dash gives me what? A dash plus B dash. Then A minus B whole dash gives me what? A dash minus B dash. And AB ka whole dash gives me what? A dash B dash, which is absolutely wrong. Please do remember, AB ka whole dash does not give me A dash B dash. It gives me what? B dash A dash. The reversal law holds over here. As matrix multiplication is not commutative, that is why AB ka whole dash gives me what? B dash A dash. Please do remember this particular thing. Then we have A dash ka dash would give me what? The A matrix back, the original matrix back. So please do remember, A plus B whole transpose gives me what? A dash plus B dash. A minus B whole transpose gives me what? A transpose minus B transpose. Then please do remember, AB whole transpose would give me what? B transpose A transpose. It will not give me A transpose B transpose. Please do remember, this is the correct explanation for it. And then A transpose ka transpose would give me A. You can make a note of this properties of transpose as well as the definition of transpose. Now we move ahead to symmetric and skew symmetric matrices. Now this is something very interesting, and this is a different behavior that we have about matrices, that is symmetric and skew symmetric matrices. Now what is a symmetric matrix? A symmetric matrix is a matrix in which when I transpose, I get the same matrix back. That is A dash is equals to what? A matrix. That is Aj would give me Aij. Now please do remember, this occurs only in case of square matrices. This is an important point to remember. Transpose was there in any particular matrix. Transpose could be done with any order. If it was a 2 into 3, I was getting a 3 into 2 matrix. But symmetric can done only in case of square matrices. That was, it would be a 2 into 2 or a 3 into 3 matrix. For example, if I have a 3 cross 3 matrix, A as AHG, HBF and GFC. Now see, when I transpose it, see the first row would become the first column, so AHG would become AHG. second row would become the second column, and third row would become the third column. So I have got the same matrix back. Why is this happening? Have you observed any particular thing? Why does this happen? If you see the upper triangular matrix that I have and the lower triangular matrix that I have, both are what? The same. Here the upper triangular matrix is also HGF and the lower triangular matrix is also HGF. So that is why this is happening. That is why AJI is equals to AIJ. So this is an example of a symmetric matrix. Please do remember, A dash is equals to A. That is my definition for a symmetric matrix. Now, a skew symmetric matrix. What is a skew symmetric matrix? A skew symmetric matrix is a matrix in which A dash is equals to what? Minus A. Now, this again occurs in case of square matrices only. Please do remember, skew symmetric matrices also occur in case of square matrices. That is, AJI is equals to minus of Aij. For example, if I have a matrix A as 0EF minus E0G and minus F minus G0. Now when I transpose it, the first row would become the first column, second row would become the second column, and the third row would become the third column. I take out minus sign common from the entire matrix. First row minus common, second row minus common, third row minus common. So what do I get over here? I get the same matrix back. So I've got A dash is equals to minus A. So that is a skew symmetric matrix. Have you observed anything unique about this skew symmetric matrix? What is something different that you see in this skew symmetric matrix? Yes, you're absolutely right. The diagonal elements are 0. So please do remember, in case of a skew symmetric matrix, the diagonal elements are always 0. In case of a skew symmetric matrix, the diagonal elements are always 0. Why does that happen? See, I have A dash is equals to minus A. So that means what? AJI is equals to minus of Aij. Now what are the diagonal elements? The diagonal elements are those elements where I is equal to j. Diagonal elements are I is equal to j. So what does this take? This takes up AII is equals to minus of AII. So what do I get from here? 2AII is 0. That means the diagonal elements are always 0. This can be asked as a 2-marker or as a 1-marker question. Show that the diagonal elements of a skew symmetric matrix are 0. So you can make a note of this. This shows me that the diagonal elements of a skew symmetric matrix are always 0. So what did I do? A dash is equals to minus A. So AJI is equals to minus of AIJ. Then for the diagonal elements, please do remember I is equal to j. So I replace the j with I. So what did I get? AII is equals to minus of AII. So 2AII is equals to 0. Now we would be taking some questions on symmetric and skew symmetric matrix. So we just now learned transpose of a matrix. So let us take up a question from our textbook. Exercise 3.3, question 2, first part is what I'm taking up over here. I have a A matrix given to me and I have this B matrix given to me. I'm supposed to prove that A plus B whole dash is equals to A dash plus B dash. This is what I'm supposed to show. So please do not directly start showing it. We'll take up the LHS first. So when I do A plus B, I have to perform normal matrix addition that we do. You remember how we performed matrix addition? We added the corresponding elements. So that is what I'm supposed to do over here. So you can perform simple matrix addition. So what do you get from here? You get nothing but minus 5, 3, minus 2, 6, 9, 9, minus 2 plus 1, so minus 1, 4 and 2. This is what we get. This is my A plus B that I have found out over here. Now I'll do A plus B whole dash. So that means I have to transpose this particular matrix. So the first row becomes what? The first column. So this would become what? Minus 5, 3, minus 2, 6, 9, 9, minus 1, 4 and 2. So I mark this as 1. This is what is my LHS that I have done over here. This has given me A plus B whole dash. Now my RHS, what am I supposed to do? A dash plus B dash. So the A matrix that I have, I would transpose it. So this would be what? Minus 1, 2, 3. The first row would become the first column. Now I would transpose the second row would become the second column. So 5, 7, 9. Third row would become the third column. So minus 2, 1, 1. Plus B dash. B dash again what? The first row would become the first column. So minus 4, 1, minus 5, 1, 2 and 0. 1, 3 and 1. So now same ways I perform my normal matrix addition that we have done earlier. So I get this as minus 5, 6, minus 1, 3, 9 and 4, minus 2, 9 and 2. So from here, from 1 and 2, if you see, I've got LHS is equal to the RHS. I have got both of them to be equal over here. Let us take up another question now. I take up question 4. It is given to me that A dash is minus 2, 3, 1 and 2. That is A dash given to me, and B is given to me as minus 1, 0. 1 and 2, that is what is B given to me. Now I'm supposed to find out A plus 2B ka whole dash. A plus 2B ka whole dash. Now please be careful. This is A dash that is given to me. If you perform A plus 2B ka whole dash, you will tend to make a mistake. So what am I supposed to first do? Transpose this matrix. So I get minus 2, 1, 3 and 2. So now I have got my A matrix from here. Now when I do A plus 2B, I have to multiply the B matrix with 2. I get A plus 2B as minus 4, 1, 5 and 6. This is A plus 2B that I have got. Now I'll perform A plus 2B ka whole dash. So this would give me minus 4, 5, 1 and 6. So please do remember, here I had to do what? A dash ka dash. If you would have directly used it, it would have gone wrong. So first I did A dash ka dash. I got A. Then I did A plus 2B. So I multiplied the B matrix with 2. I got A plus 2B as minus 4, 1, 5 and 6. And then I transposed the entire matrix. So what do I get? Minus 4, 5, 1 and 6. So that gives me my required particular answer.